Alright, this is PreCalculus Math Analysis, Section 7.2. This is part 2 of the notes. Here's where we left off. We talked about multiplying matrices. The next slide is an application. So sales revenues. Suppose that a florist sells roses, lilies, and orchids in small and large bouquets. On a Saturday, the florist sold 12 small roses, 6 small lilies, 8 small orchids, 3 large roses, 4 large lilies, 1 large orchid. If a small bouquet costs $5, a large bouquet costs $8, write and solve a matrix multiplication problem to figure out the sales for each flower. The first thing to recognize is that we are going to need a matrix of the flowers that is given to us in the table. It costs $5 for a small and $8 for a large. So we'll have a matrix that with 5 and 8 in it, but it's important to understand that we can't write the matrix like this, because that would not multiply together with a 2 by 3 matrix that is here. 5 times 12, and then there's no number to multiply with the 3. So the one trick we have to do is we have to set up the price matrix as a row. This is a 1 by 2 matrix times a 2 by 3 matrix. So that works. Let's go ahead and multiply it. 5 times 12 plus 8 times 3. And then the next one, 5 times 6 plus 8 times 4. And then the last one, 5 times 8 plus 8 times 1. This is going to give us a matrix with 1 row and 3 columns. So that's a 1 by 3, 84, 62, 48. There's your application question. $84 worth of roses, $62 worth of lilies, $48 worth of orchids. Now, the next part of this section, we talk about the identity matrix. The identity matrix is given by 1s along the diagonal and 0s everywhere else. Note that for any matrix A multiplied with its identity matrix will give you the same matrix. And that will also be equal to that identity matrix multiplied with the matrix A. Okay, we should make this a little bit more specific for the time being, and we'll say that for any square matrix. Okay, so we're going to set it up nicely. The inverse matrix A inverse, so that's not to the negative first power, that's called A inverse, is a matrix such that A multiplied with A inverse will give you the identity matrix. And in this particular case, it is also commutative. A inverse times A will give you the identity matrix. Normally, matrix multiplication is not commutative. We are dealing only with the identity matrix, and so in this particular case, we can do that. Our first example, check if two matrices are inverses. I want you to make sure that you change the top right entry in D to 1/4. And we are going to check that C times D equals I. Those are some strange letters, but let's try it. At this point, I would encourage you to stop the video, perform that multiplication, and see if you can get an answer that tells you whether or not C and D are inverses. All right, here we go. If I multiply these two matrices together, I will have 6 times negative 1/12 plus 3 times 1/6. The next entry, negative 6 times 1/4 plus 3/2. And then the third entry in the second row, first column, 2 times negative 1/12 plus 1/6. And then the bottom right, 2 times 1/4 plus 1/2. That's my new matrix. So let's put it all together. It should equal 1, 0, 0, 1. Because I got the identity matrix, we can say that C and D are inverses. This is the first type of question with inverses. Check that two matrices are inverses. There is another way to find the inverse of a square matrix. We can use, you guessed it, row echelon elimination. We could also say that's Gauss-Jordan. So we can use Gauss-Jordan elimination to find the inverse of a matrix by setting up an augmented matrix. AI equals we'll put that vertical line there. That's my augmented matrix. Use row operations to shift that identity matrix to the left-hand side. And you will get different entries. B, row 1, column 1. B, row 1, column 2. B, row 2, column 1. And B, row 2, column 2. I've only done this for a 2x2 matrix with these entries, but we can extend this to any size square matrix, 4x4, 6x6, 3x3. And this is going to be IA inverse. If you cannot reduce the matrix, it is called singular or not invertible. Find the inverse of the matrix A below, with entries -2, 1, 4, 2. Here we go. I am going to multiply the first row times -1/2. That leaves the second one the same. Then I have a 1 on the diagonal left, which is good. Let's multiply -4 times R1 and then add it with R2. That's to change the second row. Next, I can divide row 2 by 4, which is the same as multiplying by 1/4. After that, how about I multiply row 2 times 1/2 and add it with row 1. So, if I now take a look at my new setup, I have the identity matrix on the left-hand side, and this implies that A inverse will be the matrix -1/4, 1/8, 1/2, and 1/4. And I am finished. Please be sure to comment on this video in order to earn credit, take notes on it, and then have a nice day.